Okay, so let's have a look at this question. So question 9. In the given circle, O, so here O, is the center and the angles X and Y are marked. Okay, so we have the angles X and Y. So this is the center, this is Y, and this is X. Copy this figure and mark in another angle X and another angle Y. So other angles that are equal to X and Y. So what we can say is that if this is the center point, we can say that this line and this line and this line are all radiuses from the center points. Okay, so they go from the center point to the edge, center point to the edge, center point to the edge. So therefore they have to be of equal length. Now if they're of equal length, that will mean that if we focus on this triangle here, it means that this length and this length are the same, and if the two lengths are the same, then it's an isosceles triangle, so therefore this angle here is going to be equal to y. Okay, so it'll be y. So that angle will be y. And then the same on this side. So if this length and this length are the same, then this guy here is also an isosceles triangle. And therefore this angle here will be equal to x. So the angles will be equal to each other. So in an isosceles triangle, the two sides are equal, therefore the two base angles are equal. So two sides are equal, the base angles are equal. So that's the first part. So that will be the answer. So you're drawing in your angles. Explain why x and y is equal to 90 degrees. So we have here x plus y. So again, whenever we have a circle, and if we, let's say, divide that circle in half, so we have two semicircles. Wherever I draw a point on that circle, and if I connect that up, do that one a bit better. If I connect that up to the ends, see my lines are not very straight. Okay, so here to here, that's always going to form, so that's always going to form a 90-degree angle. No matter where I put this point, I draw, so I put a point here and I draw a line from here to here, okay, it's going to form a 90-degree angle. So it's always going to form a 90-degree angle. So if we have a look in here, so what we have is we have we have a circle divided in half. So what we have then is this point here, and we can see that we have this arm and then this arm joining to this point here. So therefore that means that this overall angle inside here has to be a 90-degree angle. So therefore y and x is equal to 90 degrees. So that's why. Okay, so it's angles inside a semicircle are always going to be it's always going to be a 90-degree angle when you have this kind of setup. So let's look at this then. Question 10. So PT is a tangent to the circle T. So we have this PT, it's a tangent. So if it's a tangent, that means it's a line and it touches the circle at one point. Okay, so it's that point there. The center of the circle is O, so this is the center of the circle. PT is 6 centimeters, so P to T is 6 centimeters. Okay, so that's 6 centimeters. And O to N, the line O to N, so O to N, okay, which is, I guess, this point here. So O to N is equal to N to P, so it's equal to N to P, okay? So the length from here to here is equal to the length from here to here. Okay, so okay. What is the angle OTP? So the angle OTP. So again, if this is a tangent here, okay, you're always going to, this here, it's going to form, this line will be, if it goes into the center, it'll be perpendicular. Therefore, this angle has to be a 90-degree angle. So when you have a line and if it forms a perpendicular line out of it, this angle, it will be a 90-degree angle. So that's what's going on here. So we can say that what is the angle OTP? So OTP is equal to 90 degrees. 90 degrees. Find the length of the radius of the circle. So we were trying to find the length from here to here. So let's have a look and see what we can do. So it tells us this length here, which is 6 centimeters. So let's think about how we can do this. So we can see here that we have a, if I take this triangle out, we have a right angle triangle. Okay, so it's something like that. Okay, so it's a right angle triangle. This here is a 90-degree angle. It tells us that, let's say this length here is 6 centimeters. And then what it says then is that, let's say we can break this in half like so. Okay, and we can say that this length and this length are equal to each other, and then it tells us that this length here is also equal to this. So we can split this in half, and then this side and this side are equal in length, and it'll also be equal in length to this side here. So if we take that, and let's have a look, and if we just call this R, okay, so we'll call each of these lengths R. So this is R, and this is R. So this length here is 2R, so it's 2 times the radius, okay, and then this length here is just R. So what we can do is we can use Pythagoras' theorem, so we can say that 2R to be squared, okay, so that's just these two lengths here. So this length is just 2R's, plus R to be squared is equal to, let me change that now, so it's going to be, so 2R to be squared, okay, so that's this side here, is equal to 6 squared plus R to be squared. Okay, so we can say something like that. So if we, so let's try and work this out then. So this is just going to be, so R squared is 2R multiplied by 2R, which will just be 4R squared, is equal to 6 squared plus R squared. 6 sixes, so 6 by 6 is equal to 36. So 4R squared is equal to 36 plus R to be squared. Okay, so now what we want to do is we want to try and collect up all the R squareds on one side. So if this is plus R squared, we can minus R squared from here. Okay, so those two will cancel out. And then we have to minus an R squared from this side. So that will leave us with 3R squared. 3R squared is equal to 36, like so. Then what we can do is we can get rid of the 3, so we can divide this side by 3 and this side by 3, so they will cancel out, and you'll be left with R squared is equal to 36 divided by 3, which is 12. So let me just double check, 36 divided by 3, which is 12. Okay, so R squared is equal to 12, and then in order to get rid of this square power here, I can get the square root of this and the square root of this. So they'll cancel out, and R will be equal to the square root of 12. So the square root of 12, which is equal to 3.46. 3.46. So we can say that the radius of this circle is 3.46. So the length of the radius is 3.46. And it'd be centimeters. Okay, so hopefully that makes sense, and I think that's it.